Okay, next I'm going to show you the process of installing the Frogpoints into the Turnout. There's 4 steps in the process of getting the Frogpoints in place. One is we insert the pre-soldered Frogpoints into the fixture. 2, we confirm the location of the Frogpoints with the NMRA gauge or a set of wheels that we've confirmed are in gauge. 3, we solder the Frogpoints to the PC board tie. And 4, we solder the frog point itself, either to the wing rails or to the bottom of the PC board tie. When the frog points are placed into the rail grooves in the turnout fixture, there's a slight amount of play back and forth. And what that's from is there's a bit of clearance between the width of the base of the rail and the width of the groove that it's sitting in. There has to be clearance in there, otherwise you wouldn't be able to get the piece of rail in or out. So this slight amount of lateral play can actually affect the performance of the turnout. Because if you pull it all the way back, you can actually increase the width of the flangeway, and pushing it forward will make it a little bit narrower. There's a couple of ways to confirm that we have this sitting in the right place. The most precise way is to use an NMRA track gauge if there's one available in your scale. Now, not all the scales have NMRA gauges available, but we're working with HO and I do have one, so I'll show you how to use it to confirm that you have your point rails in the right spot. So what we're going to check is what's called the check gauge. And the check gauge is the distance between the inside edge of the guardrail and the inside edge of the frog point. NMRA track gauge has little tabs on it for doing this test. What we're going to do is drop those flangeway tabs down into the flangeways. We're going to push it this direction so it's sitting up against the edge of the guardrail like that. Then we're going to rock it in and out and make sure there's no interference with the point rail, which there isn't. And this rail is pushed all the way forward. If I back it up, we'll actually increase the clearance more than it's required. And we can see this if I do it the other way. If I put the flangeway tab on the frog point and rock back and forth this direction, you can see where I'm hitting the guardrail. So that's clearly not in the right spot. So we get it all the way forward, and now we can get it in and out without any interference. And that's exactly the results we're looking for. And this side here will be the same, rocking it back and forth. It just fits in there perfectly up against the frog point, and then we can check it the other way, rock it back and forth. There we go. That's exactly what we want. So in this setup, the points pushed all the way forward gives us the best results. There's another way to check that's equally effective, and that is to use a set of wheels that you are perfectly confident are in gauge. You just roll them back and forth through the turnout and see how it performs. And if it feels nice and smooth, then you're getting the results that you want. Then that's the correct position for the frog point. That's good. It's nice and smooth. Now you can see a little bump in the wheels there as it rolls through the frog, and I'm going to show you why that is. The tread on a set of wheels of all railroad equipment is actually tapered. So it's actually a smaller diameter here than it is here. The reason for that is so the wheels will track properly when they go around a curve. So that does cause a bit of a bumping effect when wheels go through a frog point. So what's happening is the wheel's rolling through the frog, it's actually rolling on this tread, on the outside edge of this tread. And as it gets farther and farther in here, now it's the smallest diameter of the wheel is touching the wing rail. But when it picks up onto the frog point, now we're actually making contact with this part of the wheel. And this is a larger diameter. So as it gets to the frog point, it's going to want to lift up ever so slightly, because that's the difference between the diameter at this location and the diameter at this location. And mind you, it's only a few thousandths of an inch, the difference. But it is enough that you'll notice when you push trucks through like this on their own, you'll see it bump up a little bit. And that's normal. All equipment will do this. It's not going to cause an issue when you get a fully loaded train car on there that has the proper weighting on it. It won't even be noticeable. On a single set of wheels like this, you will notice a little bit of a bump as it rolls through the turnout, but it's nothing really to be concerned with. So now that we've confirmed the location of the frog, we know that in this situation, pushing it all the way forward was giving us the best results. We're ready to solder in place. Nothing special about this process, just apply a little bit of flux and a couple of solder joints, and the frog will be in place. And like all the other soldering we're doing, it's vital that you it's vital that you make sure that the rail is sitting flat on the ties as the solder cures, especially in the frog point, because you want to make sure that the tip of this point isn't lifting up, because it'll just make a very noticeable bump as the wheels go through the turnout. Now when we solder the frog in place, we've got 4 nice solder joints here, but really there's nothing holding the point down. I'm going to show you what this can cause when the turnout is removed from the fixture. Because there's nothing holding the point down in this location, a little bit of misalignment on your road bed can cause the frog point to want to lift up like that, and that's definitely going to give you issues when you operate. So there's a couple of simple ways of fixing that. One is we can turn the turnout over and put a little bit of solder underneath the frog point. So if you put a little bit of flux in here and apply a little bit of solder, it'll wick down in underneath here and hold that solid. There's another way that works very well too, is we return the turnout to the fixture and we get a little bit of solder down in the flangeway, right in here above this tie. So if we put a little bit of flux down in there and a little bit of flux here, we'll get some solder down in here, and that'll solder up everything nice and solid. Now this only works in on larger scales from about HON3 and up. If you're going smaller than that, N scale, Z scale, you will have to solder in from underneath. The advantage of this technique is that you're doing it with the trackwork still in the fixture, so there's no chance that you're going to melt the solder joint that's holding the 2 frog point rails together and cause it to go out of spec. This way, when you're soldering it down in the fixture like this, everything is still held in place. Now I'm getting the soldering iron tip right down in the flangeway, and I'm going to touch a little bit of solder right to the tip and let it flow down onto the tie like that, and then pop that back out and let it harden. I'm going to do the same on this side, right down inside the flangeway, and then applying some solder onto the tip like that. Let it flow. You can see I'm leaving the heat on there for a few seconds. Take it out and let it cure. Now I haven't put a whole lot of solder in there, just absolute minimum amount, because you don't want to get too much in there and it'll interfere with the equipment rolling through the turnout. The amount I use is very small, so it flowed right down in. You can check it with wheel set. You can see that there's nothing interfering with the flanges there, both straight route and diverging route. When we pop this back out of the fixture, now we can see that that can't move up and down. That's soldered nice and solid. Now, even though I've soldered this frog point in with the flangeways, I'm going to show the process required to soldering it from underneath, just for those that are using smaller scales and have to do it this way. I like to take the turnout out of the fixture and then set it upside down on the fixture. This way you know you've got a nice flat surface to work on. We're just going to add a little bit of flux down here and here, right to the bottom of the rail, right in front of that PC board tie. And then when we add some heat and solder to it, as the flux melts, it'll draw that solder down in underneath the rail and solder it nicely to the PC board tie. You don't need a lot, and you don't want to spend a lot of time with this, because you don't want to melt the other solder joints. So I'm just going to leave a bit of heat on there like that and let it wick down in underneath. Just like that. I'm going to apply a little bit on this side as well, like so. Doesn't look pretty, but it's quite effective. Now when I turn it over, this is definitely soldered solid to the PC board ties.